Okay, so this is review part 2, and I'm talking about number 4. We're going to talk about whether these people are accurate or precise or both or none. So Jamil, all of his measurements are pretty close together. They're within 2/10 of each other. So I would say that he was precise. What was the accepted value? The rock's mass was 5, so I would say he is precise and accurate. Because he's super close to 5, he got it right on a couple of them, and his whole group is close together. Cody, he did not do so well. He is not accurate at all, but he's pretty precise. And then Rachel, Lord knows what she was doing. She is not accurate, she is not precise. What about Juan? What would you say about him? Okay, not accurate but precise. Okay. All right. I think we're good at the bottom. I'm going to the next page. Anything 6 through 12 I need to talk about.
The law of conservation of matter and mass, they're the same thing.
That is the same thing. I can say that mass can't be created or destroyed, or I can say matter can't be created or destroyed. Only changes form. Exactly the same thing. And the law of conservation of energy is exactly the same. Can't be created or destroyed, just changes form. All right, how about 13 through 17? No trouble calculating density, right? We can all do that?
Yeah.
Okay. Then I'll go to the next page. Anything on there you want me to talk about? 18 through 21.
When something is more dense, it's like heavier, right?
If it's more dense, it has more stuff in less space. So if something is more dense, if one thing's more dense than the other and I put them together, the most dense thing goes to the bottom. So if you're given a list and asked to like put it in order, be sure that you tell me where the most dense and where the least dense is, because on one of the questions I noticed, it wasn't this class I don't think, but it might have been 8th period, where they were listing the densities, they were putting the most dense on the top. But the most dense thing would be on the bottom, because it's the thing that's going to sink. So be sure you label which way you're doing it. When I look at this liquid and the densities, the thing that would be on the top when I look at this would be the lamp oil, followed by the vegetable oil, followed by the water, and then the honey is going to be sitting at the bottom. Okay, back of that page, 23, 24, 25.
For the state. You just go down the list.
Sure. The state phase involved in the change, it would be liquid to gas for the first one, gas to liquid for the third one, and solid to gas for the last one.
Can you list the kinetic energy?
Can I what?
Can you list the next column?
The energies? Oh, does KE increase? Okay, I gotta look at this. When water boils, kinetic energy increases because there's more particle motion. When ice melts, kinetic energy increases because a liquid has more particle motion than a gas. When water vapor condenses, kinetic energy decreases because a gas has more energy than a liquid. And when a solid becomes a gas, kinetic energy increases because it's more random. How about 25? Are we good on those? Anybody need those checked? No? Okay. Then, oh, there's another 25. Okay. How about 25 number 2? Through 29. Anything there? When you calculated your percent error, what'd you get for an answer, Bailey?
427.
For 27, yeah. 35.1? Ooh, that's a little high. Let's look at that. So we had 11, you should have had 11.4 minus 11.36 over 11.4 times 100. When I did that, and get your calculators out and check this, but when I did that, I got 0.35%. Maybe I need to check it. Maybe I forgot to multiply by 100. No, 0.35 it is. Okay. You guys good with the formulas down below?
Yeah.
Okay. Back of that page. What has to be true about a chemical reaction? What would you tell me, Delaney?
It holds up the law of conservation of mass.
Yep. Holds up the, or obeys the law of conservation of mass. Mass of products has to equal mass of reactants. I can't just make something up. Anything else on that page we need to talk about? Okay, next page. 6 through 10, anything? What are the three major divisions of science?
Life, physical.
Yep, life, physical, earth. Good. Back of that page. You guys, when you do your 7 diatomic molecules, if you're asked to give them, be sure you give the formula. That is the diatomic molecule hydrogen, not just writing hydrogen. Can I what? Oh, yeah, maybe. You want to see?
Just a tad.
I should quit using a pencil, too. Maybe if I got something that was actually black, you might be able to see it. So, if I ask you for diatomic molecules, don't give me their name, give me their formula with their state. Okay. Next page. What two things are considered a pure substance? I got lots of questions about that. Good. Element and compound. Element, atom, compound, you can say any of those three. Did you have to do anything to number 16 to balance it? Nope, wasn't that nice of me. I gave you one that was already balanced. Okay, back of that page. 16 through 20. That's all pretty simple stuff. Next page, 21 through 26.
How do, for 23, how do all the terms relate? I just
No,
know that- I just
23.
said that they all
Okay.
Avogadro's
So the thing that relates them is the term mole. Mole is the quantity in grams which is molar mass that equals 6.02 times 10 to the 23rd atoms, which is Avogadro's number. So the mole puts the two things together. The mole's like the linker between the two. Yes, Bailey?
Well, number 22, where do you just want to split the guy?
He's the guy that figured out how many atoms are in 1 mole of anything.
Okay, so that's what you must split.
Yep, that's all you know about him right now. Well, maybe you know more. I don't know. Do you know more about him? Okay. What's his first name? Anybody? Emilio. Emilio Avogadro. Okay. Next page, 27 through 34. What's the difference between hydrous and anhydrous?
Hydrous has water in the equation.
Hydrous has water, anhydrous does not. See if you can write this. I don't think I put one on there, but let's say we have sodium chloride with 5 parts water. See if you can write that in a formula. You remember how to do that? Yeah? Was that a
I don't know if I did it right.
What'd you do? You think I can see that?
No.
I can't see what's right in front of me. Hey, that's right. This is what you did. See if you did it. Good job. Sodium chloride with 5 H2O. That's the way you write it. So if you see a formula like this, you know it's hydrated or it's hydrous. If this isn't here, that would be an anhydrous formula. All right, let's move to the next page. Anything on there you want me to go over math-wise, 35 through 41? Anything you want me to work?
What's the units for the 4-step?
What's the units for what?
The 4 steps for geometry problems? Because like the 3-step is like grams to atoms.
Oh, if it's a 4-step problem, it's where you have to use a mole ratio from your formula. Anything on there you want worked? 40, 41? We good? Okay. Back of the page, there's several more. 42 through 46. 46 might be one that you had to really look up.
Yes.
We just go over that.
Can we what?
Just go over it.
You want me to do 46 or you want me to go over the whole page?
Or just like, yeah, go over 46.
Go over 46, okay.
That's okay.
So when I'm finding the average atomic mass, I have all these isotopes, and what I do is I take each isotope, like I'll start with the first one, 27.9769 grams times, and I turn my percent into a decimal, 0.922297, plus, and then I do the next one, 28.9765 times 0.046382 plus the last one, 29.9738 grams times 0.03872. So I take my percent, turn them into a decimal, add them all together, and if I remember correctly, I think I got 28.07. Yeah, good? Just don't forget to put them in decimal form. Now let's check answers on 42 through 45. Alyssa, what'd you get for 42?
I got 7.6 times 10 to the 3rd.
Good. What'd you get for 43, Kalia?
0.986303.
Okay, so 0.98 moles would be good. And number 44, you'd be surprised how many people ask me about this question. All you had to do was read it. The answer is right there. 5.4 times 10 to the 31st. How about number 45? What did you get for an answer? Olivia?
I got 9.60
Yep, 9.6 times 10 to the 23rd. Any of those you need to see? Okay. How about this last page with the table? Well, it's not really the last page. How about the page with the table? One thing that I saw a mistake on a few of them, if you look at chlorine, see how it says Cl-37, whatever the dash is, whatever's after the dash is the mass number. That's what you use. You don't go to the periodic table. So when it asks for mass number, you should have 37. That's also what you subtract the atomic number from to find the number of neutrons. So I would have 37 minus 17, which means there's 20 neutrons. Is it the most common isotope, chlorine 37? Does it match the periodic table? No, it does not. Only Delaney wants to answer me. How about magnesium 24, most common or not most common? What is? Yes, it is. Okay, last couple pages. Anything we need to talk about? Yeah.
Did you go back and do 45?
Can I get back and do 45? Yep, I can. 45. Okay. So this is number 45, review 2. How many atoms are present in 0.450 kilograms of K2SO4 with 6 parts water? So get your periodic tables out and get your calculators out. So if I have 0.450 kilograms, the first thing I have to do is convert to grams. So that is 450 grams. So I have 450 grams of K2SO4 with something, with 6 H2O. and I have to get all the way to atoms. So if I'm going from grams to atoms, how many steps? 3. Okay. So if I have grams here, I know I need grams here, and I know I have the conversion factor of how many mole or how many grams in 1 mole. So I have to find my molar mass. I've got potassium, and there are 2 of them. I've got 1 sulfur. I've got oxygen. I'm going to say there are 4 of them. I've got water. I'm going to keep that together. And I've got 6 of those. So potassium, I need my little periodic table. There it is. It's 19 or 39, I forget.
I think there's 10 oxygen. 'Cause there's a.
Well, yeah, there are, but I kept my water by itself.
Okay.
So you're not wrong. You might have done it different than me. So I have 2 times 39.1, 1 times 32.1, and I've got 4 times 16 here, and then down here in my water, I've got 6 times 18, because 1 mole of water is 18 grams. Move that up. Now I need to add them all together. When I add this all together, before I got, see if I'm right, 282.3 grams. Yeah? So that's your molar mass, so that goes down here, 282.3 grams. I'm done with grams. I'm in moles, but I don't want to be in moles. So I need 1 mole down here, and then I say to myself, how many particles are in 1 mole? 6.02 times 10 to the 23rd. Now, I saw different answers than what I had for this, but people had it set up absolutely right. It's because you're not putting your parentheses into your calculator. And if you don't put your parentheses in your calculator, it doesn't follow the rules for scientific notation. It messes you up. So try putting it in like parenthesis, can't read, 450. Well, first I have to turn my calculator on. 450 divided by parenthesis 282.3, enter, times parenthesis 6.02 times 10 to the 23rd. I got 9.6 times 10 to the 23rd atoms K2SO4.6H2O. Is that what you got, Olivia, when you said it before? That's what I thought. Anything else on that page? All right, we're running out of time. Let's move on to review 3. That seemed to be the one. That's the one I think I actually made notes on your papers on 3 for some of you. I don't remember. Let's just flip through page by page. First page, on the front of the first page, your molar masses. Check those, 162.3 and 78. Okay. Moving to the next page, I don't see anything on there that you shouldn't have in your notes. The following page I put on classroom for you. The first one I really wanted to look at was on the top of page 3. It says give the total number of atoms present in the compound. So this was my compound, FeClO4 4 times. Iron 3 perchlorate. How many atoms are there? If you're not given grams or anything, it doesn't say how many atoms are in 412 grams or anything like that. You just work with the compound. So when I look at this, I have 1 atom of iron. Is that supposed to be? That should be a 3, not a 4. I have 1 chlorine here times 3. That gives me 3 chlorine. And then when I look at oxygen, I have 4 times 3, which gives me 12 atoms of oxygen. So 1 plus 3 is 4, plus 12 is 16 atoms total in iron perchlorate. Okay? Anything else on that page, moving down the list, that are on the page with all the math? I have 0.66 mole is the answer to the next one, followed by 4,570.5 grams, followed by 0.35 grams. That's one that I saw a lot of mistakes on, that had the right setup but the wrong answer. Again, it's a parenthesis thing. And then I had to correct some down below. Diphosphorus non-oxide is P2O9. Aluminum sulfate, notice how that ends in ATE? that means it's not straight off the periodic table, it's one of your polyatomic ones. So watch for that on the test, because you're going to have to look some of them up. That should be Al2SO4 3 times. Carbon octahydride is just CH8. And zinc chloride, a lot of people mess this up. Zinc is a 2+. If I go to my periodic table, chlorine becomes chloride. It's a 1-. Your neutral formula is ZnCl2. It takes 2 of these to cancel out 1 of these. Some people had just ZnCl, or somebody had ZnCl3. You have to remember your magic triangle. Ag is a plus, Zn is 2+.
Will naming compounds be on the math part?
Well, what?
Will naming compounds be on like the math?
Oh, I'm trying to remember. I'm not trying to lie to you. I'm just trying. I think it's more like I gave you the name and you have to make the neutral compound.
Okay.
Okay, so balancing equations, everybody did fine with that. And then we seem to be okay with the Lewis structures. Anybody need to see any of those? The second one, the H2CS.
No, the carbon ion.
Yeah, sure. So carbonate, I have to think about that, is CO3 2-, which I didn't give you. Then I go, okay, carbon has 4 if I go to the periodic table. Oxygen has 6, but I have 3 of them. Plus, it has a 2-, that means I've added 2 electrons. So that's 4 plus 18, which is 22, plus 2. That gives me 24 electrons to work with. So, all I need to worry is that I don't use more than this. So I'm going to take carbon and put it in the middle because it has the most places for attachment. And I'm going to hook up my 3 oxygen. I've used 6, and then I'm just going to start filling in so everybody gets 8, but count as I go. So 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now I'm going to stop and do a check. This oxygen's happy, it's got 8. We're happy here. Oh look, we're happy here too. Well, that was a weird smiley face. This guy in the middle, he is unhappy because he only has 6 and he needs 8. So what am I going to do? I'm going to pick from one side, it doesn't matter which, and make a double bond. So then I have C with all their little dots. Everybody's happy. Nope, those aren't there. You have to remember at the end, though, because it's an ion, you bracket it and show its charge. And in that case, everybody has 8 electrons. Everybody's happy, and we've only used 24. All right, and then we won't have one like 21 or 22. Is that right? Yeah. One thing I did want to say about this page is be sure that you are actually estimating the last digit. Like on this last graduated cylinder, you can actually read to the tenths place if you count the lines. So you would have to estimate to the hundredths place. You should have 3 sig figs. All right, let's go to the last few pages. Anything on the one that starts with frequency, wavelength, all that stuff? Yes, Bailey.
Can you go over how many electrons can each of the 7
Yes. If I think about this, I have one S. S can hold how many electrons? 2. So the first energy level can hold 2 electrons. When I move to my second energy level, I have 2S and 2P. So here's 2, here is 6. I can hold a total in my second energy level of 8. When I go to my third energy level, 3S, 3P, 3D. S can hold 2, P can hold 6, D can hold 10. So my third energy level, I can have 18. Then when I go through from 4 on, I have an S, a P, a D, and an F. So that could be 4, 5, 6, 7, 8. Here I've got 2, 6, 10, 14. If I add that up, the fourth on can hold a max of 32 electrons. Does that make sense how I got those? Okay. Okay, back of that page, there's some math on there. Anything on there you want me to work?
Will we have the card deal, the level card that you just did on our test? Like, can we bring our, like,
I'm going to give you a periodic table, I'm going to give you polyatomic ions, I'm going to give you orbital notation arrows, I'm going to give you ionic character, electronegativity. You're going to have several like resources to use. They'll all be laid out for you. The only thing you won't have are formulas. Kalia?
Give the speed of light.
Speed of light is 3 times 10 to the 8th meters per second, and its variable is c. Or if it happens to be in centimeters, it's 3 times 10 to the 10th centimeters per second. Most of the time it's in meters, though. The other one you have to know is h, Planck's constant, 6.626 times 10 to the negative 34th joules times seconds, and all those number 6.02 times 10 to the 23rd atoms per mole. So those are like the 3 big ones you have to remember.
Does that say 6.626?
6.6, yeah, that's a bad 6. 6.626 there, times 10 to the negative 34th. Okay, anything in those problems or the orbital notation? Let's look at letter E. Give the highest energy level containing electrons. For some reason, a lot of people put 4 there. For that question, all you have to do is look at what you're given and look for the highest number. The highest number is 6. So the answer to that would be 6, not 4. Even if 4 fills last, it's still not the highest energy level. I think everybody got everything right on the electron configuration. Kr, 4d2, 5s2, and then the second one was just xenon in brackets. So look through the end and see if there's anything you want me to do or talk about.
will we have to list how to, like, operate a Bunsen burner on the test?
No,
Okay.
no. Yeah, Brandon?
Could you show us how to do the noble gas configuration for only electrons in here?
Noble gas configuration, yeah, let me flip back here to one of them. Let me do it for something well, did you do the barium ion?
Yeah.
Okay, and what, did you do a noble gas configuration?
Yeah.
What did you do?
I got BA in brackets 5p6.
Okay, so barium, when you make it, barium has 56 electrons, but it forms an ion of Ba2+. If it's got a positive charge, that means it lost 2 electrons, so it would have 54 electrons. If I go to my periodic table and I look at the noble gas before barium, barium's here, so I have to go up and all the way over. It's xenon, and it has 54 electrons. So I would just write Xe. I wouldn't have to add anything. So let's do a really easy one so everybody can see it real quick. Let's look at magnesium, just because it's little. So magnesium has 12 electrons. So I would go 1s, 2s, 2p. And now I've used 10, and then next comes 3s. So there, I've used everything. That's 12 electrons. So my shorthand notation would be 1s2, 2s2, 2p6, 3s2. So I find magnesium, I hop up a row, I go to the end, and I find neon. So I would put neon in brackets, and neon has 10 electrons, so I'm going to get rid of 10. And look at what I have left. I have 3s2 left over, so I would put it on the outside. Okay, good?
Wait, where did you get the neon from?
I put my finger on magnesium, went to the row above it, followed the row all the way to the end, and the noble gas is neon. It's always the noble gas that comes before the element. Any other questions on that? All right. How about the end of it? Are we good on the rest? Okay. So let's go to the very last one and see if there's this one. I felt like this one was the easy one. The last one. I had a lot of questions about number 3 on the back. All you have to do the bond type drawing or the ionic drawing is just go to the periodic table, look at what ion it's going to form, like nitrogen. Forms an ion of N3 minus. Think about what happens to get to 3 minus. I have to add 3 electrons, which makes N3 minus. That's the whole drawing right there. That's all you have to do is figure out what your ion is, and then think, does it gain or lose electrons? If it gains electrons, you add them. If it loses electrons, you subtract them. How about 5, 6, or the one I didn't give a number? I guess that was number 11 I was just talking about. 13 through 18, any questions? I had a lot of questions about 15. Do atoms and ions have the same chemical properties? They do not, because they behave differently because ions have a charge. How about the back of that page? There's math on the back of the page. Any trouble with that? We're good there. It's just a little more stoichiometry. And then, nope. You didn't have any trouble. I don't think anybody had trouble with naming stuff. Just, what do we look for when I give you a formula to figure out if it's ionic or covalent? What makes it up? Is it a metal and a nonmetal? Then it's ionic. If it's 2 nonmetals, it's covalent. I have to use my molecular prefixes, my di, tri, that stuff. Yeah. Right, like let's look at this. Let's look at, let me make one up really fast. SF6. Is that a molecular or an ionic compound? Say to yourself, is this a metal or a nonmetal? That's a nonmetal. Metal or nonmetal? Nonmetal. So I have a nonmetal plus a nonmetal. Oh, that's covalent or molecular. So I would say sulfur. What is my prefix for 6? Hexa. Hexafluoride. And I left my O out. Sulfur hexafluoride. Okay, so then what about this one? What if I said BaO? You can't even see it. Metal or non-metal? Metal. Oxygen, metal, non-metal. Non-metal. So I've got a metal plus a non-metal, which tells me it's ionic. Now I have to think about charges. Okay, so remember to ask yourself those questions. What would this be? Anybody know? Oh, I already told you. Never mind. You know? It's right in front of you. How about the Lewis structures? We already did one of them. I told you to get rid of N3. I think the rest of them were fairly easy. Is that the last thing you guys have? Oh, you have the acid stuff. You good on the acids and bases? That's pretty straightforward.
Yeah, the 3 types are the common acid, common base, and the Lowry,
Bronsted-Lowry or conjugate acid bases, and then the Arrhenius is another name for the common.
Okay.
Okay. I hope you guys won the game.